Now, when we define the structure like this, what is really happening? It's like when you define an array, it allocates some memory space. When you define integer, it allocates some memory space. Same way, when you define a structure, it will allocate some memory space. How much memory space? Now here, that m will be a structure variable defined in components memory. M is called as structure variable, and m itself holds inside it a 2-byte integer a and a 4-byte integer b. I'm drawing this figure just for understanding sake. Actually, they will be created one after other in memory. There's no gap or something like that. There's nothing like box or something. In memory, there will be two variables created one after other, and combination of those variables will be just known by variable name m. Now, since a is 2 bytes, b is 4 bytes, the overall size of the structure m will be 6 bytes. That is, size of the structure will be equal to sum of the sizes of all the members of the structure. Okay, what are the values of a and b? They are garbage values. Now, always assume a structure is like a box, and the variables, that is members of the structure, are like contents of the box. Now, obviously, box is not very important. Box is just a container that is used to hold the things together, that is contents together. So here m is just like a outer cover or a box that is putting a and b together. We can carry a and b together just by lifting m from one place to other place. So same way we can do some operation on m as a box, or we can independently work with a and b. But obviously the most important part over will be the variables a and b and not the box, that is m, because contents of a box are important. Box is never important. Now with this, we'll go forward to understand how we can access the members of the structure. To access members of structure, they have given a syntax is a structure name dot member name. So whenever we want to do any operation with the members of the structure, we have to follow this notation. It's like in case of array, we follow some typical syntax like a of I or a of 1. So you have to write array name and the index in a box bracket. Same way here you have to write structure name dot member name. Now, for example, here m is a structure and a and b are the members. To access a and b, we can use this notation m dot a equal to 5. We can read it in bit other way. A of m structure is equal to 5. Then we want to output the value of m. How we can output it? We want to output a. So normally we should write only printf and a. But since a is a member of m, we have to write printf %d, since it's an integer, m dot a. So it is you're printing a of m. We can read it in reverse direction with of word. Scanf. Okay, we want to input value for a. Since again a is an integer, what we are inputting, you write %d and a proper syntax like and m dot a. We are inputting finally an integer, so we have to write ampersand symbol, %d, everything as it is. But variable access will be structure name dot member name. So it will be scanf m dot a, that is scanf a of m, or input a of m. Now let's see this example over here. Suppose we really write these statements, what will happen? Here you are writing m dot b equal to 2.5. So because of that, 2.5 will be stored inside b of m, that is m dot b. And m dot a equal to 10. You are saying a of m equal to 10. So in a of m, there will be value 10 stored. After that, you are saying some variable s, let's assume it's a float variable, equal to m dot a plus m dot b. So in this case, m dot a, which is 10, and m dot b are added and put into some other variable s, which is a simple variable. So value will be 12.5. So we can just work with the variables inside a structure as if we are working with normal variables. Input, output, do additions, subtractions, use them in if else, for loop, anywhere. Just use a notation structure name dot member name. Thank you.